Hey everybody, we're back for the last assignment of this week. We are doing problems 11, 15 to 17 in this video. Homework is 11, 19 to 25 and skip 22. Okay, so you had one of these in your homework last night, which was number 8, I believe, where you're multiplying and dividing fractions. There's actually two ways to do that. Math teachers will like the first way, but will tend to do the second way. So I don't know, it depends on what you like. For method 1, we are going to multiply across the top. So 2 times 9 is 18. 3 times 4 is 12. This is not cross multiplication. This is blurry, first of all. Okay, this is multiplication across. So 2 times 9, 18. 3 times 4 is 12. And then reduce. So I know 6 goes into both of those. So 3 over 2. Okay. Our friend the calculator can reduce things. Oh, look, there's that problem from the previous video. Okay, so our calculator friend can reduce fractions very easily. If you put 18 divided by 12 and you get a decimal, just hit math, enter, enter, and you'll get 3 over 2 to change that to a fraction. Okay, now for method 2, this is one I tend to do if I'm doing a math problem myself and not teaching it. I will cancel things on the top and bottom. You can cancel up and down or diagonal. So for example, this 9 and 3, I see that reduces to 1 and 3. This 4 and 2, I see reduces to 2 and 1. And then I have 1 times 3, which is 3, and 1 times 2, which is 2. Again, math teachers don't really love this. But we do it a lot with our rational expressions. We do it with our factors of like x plus 3 and x plus 3. So I wanted to make sure that I showed it here. Okay, for division, you use keep, change, flip. So keep, change to multiplication, and flip. And then you do the same technique here. So 3 times 25 is 75. 5 times 12 is 60. I know those are both divisible by 5. But I have the sweet calculator on me. 75 divided by 60. Math, enter, enter. 5 over 4. Oh, that's dumb. Of course, it's divisible by 15. Oh, miside. Okay, now for this one, 3/5 times 25 twelfths. So I'm going to show method 2, which is kind of my canceling method. I see the 5 and the 25 reduce to 1 and 5. And I see the 3 and the 12 reduce to 1 and 4. And so I have 5/4. I don't care which one of these you do, just as long as you get 3/2 and 5/4 as your answer in the end. Okay, so now we're going to take that information and apply it to rational expressions, which is our algebra work. And starting off pretty easy, 4x plus 3 over x minus 5 times x minus 5 over x plus 3. Okay, what I want you to see is that the x minus 5 on the top and the x minus 5 on the bottom down here are a giant 1. And you get a 1 by having the same thing on the top as the bottom, so I'm going to cancel those out. And I have 4x plus 3 over x plus 3. And stop there. Do not cancel those 3's, do not cancel those x's. Remember, we can't do that. We talked about that in the last lesson. Okay, however, we do need to state what the excluded values are. And remember, the excluded values are found from the problem, not the answer. So in this denominator, x cannot equal 5 because 5 will make that denominator 0. And in this denominator, x cannot equal -3 because that will make that denominator 0. Okay, b, x plus 2 over 9x minus 1 divided by 2x plus 1 over 9x minus 1. Okay, so this one is going to require an extra step because it's division. I want to encourage you guys to do the keep, change, flip right onto your paper before you write it down. You don't have to write down the division and then keep, change, flip. You can keep, change, flip it right off the ebook. So keep, change, flip. Okay. Now, we have a giant 1 of 9x minus 1. Notice the flip is nice because it gave us 1 on the top and 1 on the bottom. And so I have x plus 2 over 2x plus 1. Okay, now here's a question you might be thinking of. The excluded values, are they going to come from the original problem or after the keep, change, flip? And the answer, according to the ebook, is after the keep, change, flip. So we want both of these answers for our excluded values. This one you might not see it right away. 9x minus 1 cannot equal 0. 9x cannot equal 1. X cannot equal 1/9. 2x plus 1 cannot equal 0. 2x cannot equal -1. X cannot equal -1/2. Okay, so I have x cannot equal 1/9. X cannot equal -1/2. Okay. C. (2m plus 3 over 3m minus 2 times 7 plus 4m over 3 plus 2m. Okay. Now this one is either easy or really hard depending on what you see. What I notice is that 2m plus 3 and 3 plus 2m are equivalent because addition is commutative. So that means that you can flip them around and they are the same thing. So that makes a 1. Hopefully a few of you out there saw that as well. Okay, so that's my final answer. For this one, 3m minus 2 cannot equal 0. 3m cannot equal 2. Okay. So m cannot equal 2/3. M cannot equal -3/2. Okay, great. This is quite a long problem, so settle yourself in, or feel free to pause once in a while because your brain just can't take anymore. y minus 2 cubed over 3y times y plus 5 over y plus 2 y minus 2. Y minus 2 cubed plus 2 minus 2. Okay. Alright, what I want you to see in this problem is that the y minus 2 cubed is this. Okay. And what I can do then is cancel out one of those factors with the y minus 2 on the bottom on this side, but only one. Okay, so what does that leave me with? It leaves me with 2 left over, so I have y minus 2 squared, y plus 5 over 3y, y plus 2. There's nothing else I can do there. I know it doesn't look super simplified, but it is. So that's as best as we can get on that. Okay, now excluded values. We actually have 3 of them this time. This denominator, and then this factor, and this factor. So for this one, y cannot equal 0. For this one, y cannot equal negative 2. And for this one, y cannot equal 2. Okay, e x to the third over 3y divided by 10x squared y over 4y squared. Okay, so this one we are going to keep change flip first. 15x cubed over 3y times 4y squared over 10x squared y. Okay, you have some options here. A lot of people will like to cross cancel at this point. Some people will like to multiply and then reduce. I'm going to multiply and reduce because it just gets kind of messy otherwise. So looking at the top, I have 60 x cubed y squared. And on the bottom, I have 30 x squared y squared. So notice the x squared is here, and then I have a y here and a y here, which gives me y squared. Okay. 60 divided by 30 is 2. X cubed over x squared, what does that look like? Okay, I want you guys to imagine that it looks like this. X cubed over x squared, and I have 2 giant ones and an x left over, and then those just cancel. So 2x is my answer. Okay, now, taking a look here, in the denominator, it looks like y cannot equal 0 and x cannot equal 0, so okay, I have one more problem. It's really long, and I don't think I can shove it in the bottom of this page. So sadly, and very unsatisfyingly, I'm going to have to flip this over. 5x plus 2, 3x plus 1 over 2x minus 3 squared. Okay, now, I'm hoping that you guys are following along in the ebook. This is a division problem that is extremely long. What I'm telling you guys to do is don't write down the division problem, make it multiplication and flip the second fraction so that you don't have to write it all down twice. Please look at the ebook at this one so you can see what I did. I did keep change flip all. If you're really quiet, you can hear my dog having a dream. 5x minus 2. Did I write this down from the beginning wrong? Yes. I don't have anyone in class to tell me that I wrote it down wrong. Just have to rely on myself. Okay. X minus 4. Okay. Okay, what I'd like to do first is make sure everyone understands this is that. Okay, and then I'm going to cancel things. This is the fun part. Okay, so 5x minus 2 is 1 on the top, 1 on the bottom. X minus 4 is 1 on the top, 1 on the bottom. 2x minus 3 is 1 on the top, 1 on the bottom. And what does that leave me with? 3x plus 1 over 2x minus 3. Okay, now if you notice, I have 3 different exclusions. X cannot equal, okay, and this one I'm going to have positive 3 over 2 if I do the workout. In this one, I'm going to have positive 2 over 5, and in this one I'm going to have positive 4. Okay, last question of the week. It's probably long. Yes, it is. Okay. Here's the good news. In this one, it says we don't need to do the excluded values. We only need to do the math. 20 over 22 times 14 over 35. Okay. Well, this one is just screaming at me to do the canceling thing, but that's okay. 20 times 14, 280. 22 times 35, 770. 280, let me show this again, 280 divided by 770. Math, enter, enter, 4 elevenths. B, 12 over 40 divided by 15 over 6. Keep, change, flip. 12 times 6 is 72. 40 times 15 is 600. 72 divided by 600. Math, enter, enter. 3/25. Look at us go. Okay, now this one is a division problem. I'm going to keep change flip before I write it down because there's just too much to rewrite. Okay, this one's going to take a minute, so if your brain is dead, you might want to pause or get settled in. Okay, notice this is a binomial. It does not have the x squared on it, which means that I can do either a 2-box or just reverse distributive property. I want you guys to see that there's a 5 in common. I'm going to take out a 5 from both of them, and left over would be x minus 3. The bad news is that all the rest of them are trinomials, so they're all going to require factoring. You're going to be better at factoring after this. Okay, first fraction's done. Okay, so I'm going to make a little arrow. That one's going there. Now I'm going to do the numerator of this one. Okay, and now this one's gonna go over here. Alright. Now, if you guys did not find things to cross out, that probably means that you did something wrong with the factoring. So there should be stuff to cross out usually. Sometimes there's not if it's like a really weird one. But for these, there should be things to cross out. So we have x minus 3 on the top and bottom, x minus 2 on the top and bottom. Okay, and the final answer is 3x minus 2 over 3x plus 4x plus 4. Okay, and that's it. That's a totally fine answer for a problem like this. Don't be weird, don't feel like you need to do the box for this or distribute for that. You do not have to. That's completely perfectly good answer right there. Okay, now D. Okay, I'm going to do keep change flip again, straight out of the ebook. No, I didn't do it. I didn't do it. Thank goodness the whiteout is fixed. Okay. This one gives us a chance to practice something else. You'll see. X squared minus x minus 12. Okay. Want to make sure that you're not crossing out those 12s. That is not an okay thing to do. So, taking a look at this one, I have 12x minus 18. Again, it's a binomial. It's missing the x squared. I could do a 2-box, but what I'm going to do is greatest common factor factoring. I'm going to reverse distribute a property, just like I did with the 5x minus 15. So I know 6 goes into both of those. So I'm going to put 6, 2x minus 3. And then on the denominator here, I'm going to need to diamond in box because it's a trinomial. Alright, now, this is what I wanted to talk about with this numerator. I want you guys to see that it's divisible by 3. So I actually need to divide by 3 before I do the diamond and box. Okay, and when you do the diamond and box, you pretend that the 3 is not even there, but we are going to put it in over here in the numerator. So x squared negative 4 okay, so I have my factors x minus 4, x plus 1, but I'm going to make sure to put that 3 back in the front that I divided by before I started. Okay, and then this guy is going to go here. Okay. Whew. It's a lot of factoring, but we need the factoring practice anyway, so that's fine. Okay, I think I can cancel this and this. I think that's it. Don't cancel the x plus 3's. There's not one on the top and the bottom. They're both in the bottom, so I'll show you how to combine that properly. Okay, so final answer, we have 6 times 3 is 18. We have a 2x minus 3, and we have an x plus 1. So we have 6 times 3, this, and this. Okay, and then in the denominator, we have x minus 5 and then x plus 3 squared. There's 2 of them, so I'm going to put squared. If you put x plus 3, that's totally fine. That doesn't matter. Okay. I want to do the next one, and then I think I can skip the last one because it's just the same thing. I do want to do e though. 5x squared plus 4x minus 7 10x times plus 4x minus 21. Okay. So these two, which is great news, don't need to be diamond, box, factored, any of that. It's just 10x and 5x. We're just going to leave those the way they are. We only need to factor 2 problems on this one. Thank goodness. But I did want to do this one because I wanted to show you what happens with the 5x and the 10x. Okay, so 5x squared negative 7. The dogs are snoring. So cute. Aww. Okay, 35x negative x. Okay, now I'm going to diamond box this one. Nope, that's positive. Okay. Alright. Now to the fun part. Okay, so the x plus 7s clearly go. These x's also go because there's one on the top and one on the bottom. And 5/10, this is 5/10, reduces to 1 and 2. So this side is just 1 on the top, so 5x minus 1 times 1 is just 5x minus 1. And then on the bottom, I have the 2 from this side and the x minus 3 from this side. And you don't need to multiply that out, just leave it the way it is. I think I can skip F. It is a lot of diamond unboxing, but there's nothing weird about it. It's just almost exactly like D. Okay, you guys, have a great rest of your week. I miss you all. Hope to see you soon. Oh goodness, could you not even see? Okay, hold on, I'm gonna bring this up real quick. Make sure that you guys could see what you needed to of those boxes. Stalling so you can write it down. Hope you all are good. Talk to you soon. Bye.